All right. Greetings, YouTube. So today we're continuing with Chapter 6 for this pre-cal course. So yeah, let's just kind of get into it. So today we're going to look at section 6.4. Let me look at something really quickly. Hello. Okay. Section 6.4, Trig Identities, or Trigonometric Identities. So we want to use algebra to simplify trig expressions, and we want to establish some identities. So these can be kind of fun. It just depends, it can be fun. You just have to kind of work it a little bit. So we said that two functions f and g are identically equal if f of x is equal to g of x. For every value of x for which both functions are defined, this is called an identity. So we'll see this in action. This is easier to see in action. So to kind of review some things that we've mentioned before, we said that tan of theta is sine of theta divided by cosine. Cotan is the reciprocal, right? That's okay. Some reciprocal identities. So cosecant is the reciprocal of sine, right? Secant is the reciprocal of cosine, and cotan is the reciprocal of tan, okay? Oh no, that's okay. It's time for another one anyway, okay. I think we mentioned these Pythagorean identities as well. Did we mention this sine squared plus cosine squared equals 1? We mentioned that before, right? And then how to transform to the other trig identities. For instance, if we have sine squared plus cosine squared equals 1, how can we take that and transform it to tan squared plus 1 equals secant squared? What's the relation between sine and tan? Tan is sine over cosine. So if tan is sine over cosine, what can we do to the first equation to transform it to the second one? Divide. So if we divide the left and the right by cosine, then we get the second equation. If we divide the left and the right by sine, then we get the third equation. So we'll get this one. Anyway, we'll get the cotan squared. So even in odd identities, basically the simplest way to remember this is that all the functions are odd except cosine and its reciprocal. So by odd, we mean if we do f of negative x, it's the same as negative times f of x, right? We can essentially factor out the negative. So if a function is odd and we say we pass a negative theta through that function, we can essentially factor out that negative. So sine and its reciprocal are odd, tan and its reciprocal are odd. But being even means if we do f of negative x, then it's like the negative goes away, all right? So then, like if we did f of negative x, we get f of x. So cosine is even along with its reciprocal is also even. Hopefully we can kind of see that in action. It'll kind of sink in once we work it a few times. So this objective, first we want to use some algebra to simplify trig expressions. Let's see, 4 basic algebraic techniques are used to establish identities. We rewrite a trig expression in terms of sine and cosine only. We multiply the numerator-denominator ratio by a well-chosen form of 1. Writing sums of trig ratios is a single ratio, and then factoring. So these are some techniques. Let's see if we can see these in action. Okay, this first one asks us, it says, simplify tan of theta divided by secant theta by rewriting each trig function in terms of sine and cosine. Okay, and then show this, and then simplify this. So let's take this over to notability, to this one. Want to do a new, nope, that's not what we wanted. This one. So let's look here, and let's give this a go. Come on, go away. I want to delete that one. And then this one, I want to crop it there, here. Okay. So now we are here. So simplify, we have tan, okay, but it says by rewriting each trig function in terms of sine and cosine. So let's do that one first. We're gonna go paper, and let's get some graph paper. Okay. We'll just do black for right now. So we have tan of theta divided by secant theta. So for part A, I think that's fine. If we have tan of theta divided by secant theta, okay, I don't like how thick that is. We have tan of theta divided by secant theta, okay? So this one asks us to simplify the trig identity by first rewriting each trig function in terms of sine and cosine. So what's tan in terms of sine and cosine? Tan is, okay, so tan is sine theta over cosine theta divided by, what's secant theta? Reciprocal of cosine, right? So secant is 1 over cosine theta. Is this okay so far? So when we say one fraction divided by another, what technique do we use from algebra? Yeah, keep, change, flip, right? So we're going to use the technique of keep, change, flip. So what that means is we keep the numerator, or we keep the first one as is, so that just stays as sine theta divided by cosine theta. We change division to multiplication, and we flip the second one. So if we flip the second one, it becomes cosine theta divided by 1. So again, we use keep, change, flip whenever we say one fraction divided by another. What do we notice happens here? The cosine thetas cancel, and so that really boils down to just what result? Sine theta. See, I told you it's fun. I know we're just starting, because it always starts light, and then by the end of class, it gets really intimidating. But this is kind of how a lot of these go. Okay, the second one asks us to show that this expression, the left is equal to the right, by multiplying the numerator and denominator by 1 plus cosine theta. Okay, so let's get a copy of the original. So for B, how's everybody doing today?
Ready to learn.
Ready to learn? Ready? Okay, I see smiles.
The thing with Precalculus it's just me trying to grasp it and trying to keep going on.
It's a little bit different. It is different, and like you only get the stuff that we're talking about here. It only really appears here. In my opinion, calculus is way easier. In my opinion, yeah, but you just have to practice. The tutor should be able to help you with a lot of this stuff. I don't know if you all have been using the tutors or not. Have you been using the tutors?
I don't know if I can.
The timing? Yeah, and like that whole thing throws a monkey wrench and everything. Well, we can't complain right now. Like we just have to do our best. But yeah, so because of the whole long distance effect of it all, this is why I make Pearson available. I know it is a little bit kind of confusing, but once you do it and start doing it a few times, it's only like that initially, like when you first started. But once you kind of get logged in and get set up, it's very smooth. And like there's explanations for each question. And then also I'm available. Like what you see here, I'm able to do long distance. But you know, I can't give answers if people aren't asking questions. If I do, it doesn't really mean anything. Are we ready for next week? Yeah? Yeah? I'm not, I'm kind of weird, but I'm not really excited about all the food. The food is delicious, and I actually do like it, but I like it a little too much. So then it's like I always feel guilty, and I'm like, you're getting older, so it's like I blow up, and I'm like, come on. You know, one year we decided to do a family reunion at Thanksgiving, but we did a cruise. So like we went to like Cozumel to see the pyramids. That was real fun. So it was kind of ingenious in my opinion, or genius. It's funny how genius and ingenious mean the same thing. Is that true? Like if I say it was ingenious how they did that, doesn't that mean it was genius? So anyway, but like we did this family reunion at Thanksgiving. We went to Cozumel, and like it was savvy because because it was a cruise, buffet style meals 3 times a day, so plenty of food, and then but nobody had to cook and clean, so like nobody had to like prepare the food. It was just ready, and like and by the time we were done, we got to see like the Inca pyramid, so that was real cool. I wasn't expecting to go there, but when they said that they wanted to go, I was like, I'm there, so I just committed to it. But that's neither here nor there. Okay, so let's get back. So now this one. So this one we have 1 minus cosine theta under sine of theta equals 1 plus cosine theta over sine of theta. Okay. And so this one asks us to show that the left equals the right by multiplying the top and the bottom by 1 plus cosine theta. Okay. So what we're going to do with this one, we're going to start with the left, multiply by 1 in the form of 1 plus cosine theta, right, over 1 plus cosine theta, and then transform the left into the right. So say we start here. 1 minus cosine theta under sine of theta. So again, the instructions ask us to do what? Multiply the top and the bottom by, okay. So we're going to multiply by 1 in the form of 1 plus cosine theta over 1 plus cosine theta. Is it safe to say that this is just 1? How is this purple part just 1? Something divided by itself is, does that make sense? So the purple part is really just 1 because it's something divided by itself. So multiplying by 1 doesn't change our answer. It just changes the form into something that we can use to simplify it. Does this make sense? So this is a second technique. The first technique that we did, we wrote all the trig functions in terms of sine and cosine. The second one, we're multiplying by an appropriate form of 1 to simplify. So now if we do this, let's see what happens. What happens on top? What do we have to do with that sign? We got how? We got multiplication over addition. What's the technique? Begins with a D. I. Sign distribute. Come on. It's okay. We want to distribute. You say okay? It's okay. It's okay. Okay, so we're going to distribute. Let's distribute there. So if we distribute, we get what? Sine theta. And we get what? Sine theta, cosine theta. I don't know if that helped us. We're going to let that be for right now. Okay, we're going to come back to that. Now on bottom, can you tell me what happens? We have to use what technique? We got a binomial, essentially a binomial times another binomial. What's that technique called? Foil, right? So you might use a box vector, but yeah, I call it foiling, right? So if we foil, can you tell me the result there? First times the first, what's that one? What's the outer times the outer? No, the first times first is 1, right? I agree with that. So then outer times outer? Okay, cosine theta. Inner times inner? Negative cosine theta, okay. And then the last times the last? Minus cosine squared theta. Is that okay? Okay. What happens with those two middle terms? So this cancels this. Okay, let's keep going. Let me see. We might have to undo that top, but let's kind of keep going and see what happens. So if we keep going, okay, yeah, we're definitely gonna have to factor that top. Let's put the top back to what it was. So if we go here, the top was sine theta 1 plus cosine theta. I just undid that one. Now on the bottom we have 1 minus cosine squared theta. What's 1 minus cosine squared? So what was the first trig identity that we talked about? What's the Pythagorean identity? Sine squared plus So we said that sine squared theta plus cosine squared theta equals 1, right? So now can you tell me what is 1 minus cosine squared? So 1 minus cosine squared is sine squared. Oh my God, that train. Can y'all hear that? Oh my God, that was intense. All right. So then everything else stays the same. Does this make sense? So then what happens? Okay, so we have one sine cancels this one, it cancels one of these. So then I think we finished with our desired result. We finish with 1 plus cosine theta divided by sine theta. And I think that's where we wanted to finish if we go back to the original. Yeah, 1 plus cosine theta over sine theta. Okay, are there any questions here?
So, then sine squared plus cosine squared is 10.
Mm-mm.
I mean, 1.
Yeah. Is that okay? Okay.
So is that just like a...
That's a trig identity. Yeah, that's one of the identities that we use. Okay. Okay, let's do another one. So then C, actually to simplify this, it says by factoring. Let me get a copy. So we have tan theta cosine theta plus tan theta under cosine squared theta minus 1. Okay, let's cut. Okay. It says by factoring. Okay. So, can you factor the top for me? What does the top factor into? Mm-mm. So we can't cancel across terms. Because the top has a minus and the bottom has a plus, we will be canceling across terms. We can only cancel factors. Factors are things that we either multiply or divide. So because of that plus and the minus and the way it's written, yeah, the cosine on top with the one on bottom, they can't cancel because you can't cancel across terms. We can't cancel terms. We can only cancel factors. Factors are things that we multiply, right? So this is not all multiplication and division, so we can't cancel like that yet. But if we focus on the top, so from algebra, cosine squared minus 1, that's difference of squares. We have something squared minus something squared. Can you tell me what does that factor into? So from college algebra, that's or actually that's the one before college algebra. Yeah, yeah. Something. So that's difference of squares, right? So that factors. So that's like that becomes. Mm-mm. So that's a special factoring technique. Like that's going to become cosine theta minus 1 times cosine theta plus 1, right? Is that okay? So that's a special factoring technique from before college algebra. Okay, so now if we look at the bottom, what do the two terms on the bottom have in common? They both have, okay, so they both have tan. So if we factor out the tan, what's left? Plus, we factored out the tan, so what's left? Plus 1. Because if we had put tan there, if we tried to multiply back, then it wouldn't match up because tan times tan would be tan squared, and we don't have a tan squared. Well, we factored. So like the first term has tan times cosine. The second term is tan times 1. So when we factor out the tan, it's just going to be left with cosine plus 1. Is it safe to say that like if we multiply back, we get this? If we multiply back, we get this? Is that okay? So if that 1 were a tan, it would be a tan squared and it wouldn't be equal. Does that make sense? Okay. Let's get rid of that and that and that. Okay. So now, given this, do you notice anything? Okay. Now we can do that. So now we can cancel cosine plus 1. Now everything is multiplication and division. So now we can cancel these factors. Again, factors are things that we multiply, and we can cancel factors, but we cannot cancel terms. Let's see. Yeah, I know. I figured. I was like, I know y'all didn't get this far without knowing that. It's just a huge intimidation factor that we're trying to get over. Let me think about this. What are we wanting to show? So I feel like we can take this a little bit further. Let me think about it. Yeah, let's go further. Let's keep going. Okay, so at this point, we have cosine theta minus 1 over tan of theta. Okay, so what could we do next? Or what comes to your mind when you see something like this? Okay, what would you do with tan? Tan is, okay. So if tan is sine over cosine, then maybe you're suggesting something like this, sine theta over cosine theta. Then what? Those are terms. Why are those terms? Why are those terms? Because there is a, because of the minus. That's a minus 1. Oh, we can. Yeah, we could. We could. We would have to separate it into cosine over tan, and then negative 1 over that. But before we do that, and that's okay. Now, if you separate those into two separate ones, that's fine. You could actually do that. So if that's where your first mind is going, go with it. No, it's okay. Like, so it's better that I'd rather encourage you to go with your first mind, because when you start second guessing yourself, if you make it a habit of second guessing yourself, then you're eventually going to start second guessing yourself out of the correct answer. So if your first mind says to separate them, go ahead and separate it. That's actually okay. I thought you were canceling like you did earlier. Like, that's why I stopped it.
That's kind of what I want to do because of cosine.
Well,
I didn't see the cosine minus 1 as a whole term because I thought.
no. The cosine squared was a term, and the 1 is a term. So that there were two terms on top. So earlier, we couldn't cancel like that. But this one you actually could, because we have a monomial. We have one term on bottom. But I'm going to kind of do it a little bit different. So if you want to separate it, that's fine. I will go with it and see where does it lead you. But I'm going to do this. So we have a fraction divided by another fraction. I'm going to do keep, change, flip. So then this is going to become cosine theta over sine theta times, we got this cosine theta minus 1. Okay? Is that okay? So if we do this, if we keep going, what are we going to do on top? What does this mean? Distribute, right? If we distribute, it becomes cosine squared theta minus, oh, that doesn't help. It's not doing what I wanted it to do. Yeah, I don't think that's going to help us. Let me think about it for a moment. So if that's minus cosine divided by sine, I think we kind of get back to where you were when you separated it and you had the cosine over tan minus 1 over tan. I'm still getting back to that same spot. So I'm just going to go ahead and finish it out. So we have this, and let me show you what I get. So if we go ahead and separate like you were mentioning, this is actually the same as, I feel like this is getting worse. Let's do it. Let's actually go back. I'm going to back up a line. I'm going to get rid of this. And I'm going to just simplify what we have on that last line. So cosine over sine is cotan theta times cosine theta minus 1. I'm going to stop there for that one because things weren't like merging and it wasn't getting more simple. So let's go back and look at the results of these and then see how do we do. Okay. And let's just be consistent. I think I used like this one. Okay, so now let's go back here and see how do we do. So the first one, tan of theta, yeah, so it became sine of theta times cosine. So we got that one, so that one was fine. So sine theta over 1 minus cosine theta. We multiplied the top and the bottom by 1 plus cosine theta. And I think we got that one too, so that one's fine. Okay, so this is essentially the same thing. They didn't say how they wanted the final form. Cosine minus 1, let's see, how do we do? Yeah, so we have cotan of cotan times cosine minus 1, which is the same as cosine minus 1 over tan. Does that make sense? So yeah, that one's essentially the same. I was hoping it was like canceling things would simplify down some, but they did not beyond this point. The last one? We can't take it any further because remember I tried and I thought that like we were going to get cosine squared minus 1. If we had cosine squared minus 1 on top, then that would have just been sine squared, then it would have gone further. But nothing was canceling, so then we essentially just stopped. Okay. So they have cosine of theta minus 1 over tan. We have cosine of theta minus 1 times cotan. You see how that's the same thing? Does that make sense? Do you see how this is the same thing that they have? Because they have divided by tan. So 1 over tan is cotan. Yeah. Right. Exactly. Okay, so we're going to let that be for right now. So these were okay. So now we want to look at establishing some identities. We're actually establish this identity. We have cosecant theta times tan of theta. And we want to show that that equals secant theta. Okay. I'm actually going to go back to my other. I like Pearson. I like not Pearson, but I've been using just show that it's true, right? Yeah, essentially. So let's go ahead and do it right here. Crop. Done. Okay. We're gonna work here, and let's go back and let's get our graph paper back because that works for me. So now we're gonna start with the left and transform the left into the right. So if we have let's go like here. So we have cosecant theta times tan theta. Okay. So how can we transform this into the right? What comes to your mind when you see something like this? If we do manipulations on the left. Cosecant is what? The reciprocal of sine. So cosecant is 1 over sine of theta times tan is sine of theta over cosine of theta. Okay. So then what do we notice? Now we can do what? Now we can cancel. Notice it's all multiplication and division. These are factors, and we can cancel factors. So then that leaves us with 1 over cosine theta. But then 1 over cosine is really, see how fun that was? Hopefully you had some fun. Hopefully. I mean, they kind of get like that. Like, it's not all intimidating. When it clicks. And it's not always going to click, but the click is even more satisfying or gratifying when we have some frustration. Like if everything was easy, it wouldn't mean anything. But like if we actually had to work for it, and we work for it hard, and then we get it, it just makes it that much more satisfying. Okay, all right. So I kind of want to pause right here. Let me see. I want to play a quick game. So let me see. The game that I want to do. I'm gonna tell my phone to start a soulful Christmas. Can you guess or predict what song is gonna come on? So if I tell the phone to start a soulful Christmas like a R&B Christmas, what artist and or song do you think is gonna come on? Who's that? Mariah Carey? Oh, that's a good one. Who do you say? Oh, this Christmas. Oh, that's a good one. I'm gonna say Silent Night. Is it Aretha Franklin? Silent. Okay, I think she sings that. Okay, let's see if it works. So let me see. Um, Play a Soulful Christmas. Oh, wait a minute. Is that my playlist? No. Let me try one more time. Hang on. Start a Soulful Christmas radio. What? Okay, let me try it one more time because I don't know what that is either. Start a R&B Christmas radio. They always do this one. Can I? I'm trying to get it to like be random. Can we hear it? Oh, we gotta. Oh yeah, the audio. I don't know how to get the audio working. That sucks. Okay, I got it. So we'll let that be for now. We have to try something else next time. Okay, so didn't quite work. We'll figure something else. I'll try a different technique next time. Okay, so that feels good. So we started with the left through the trig identities. We were able to get to the right. So we're going to stand by that. We're going to go paper. Okay, so let's go back. Nope, not there. Yes. Okay, so I think we did this one. Okay, we're going to let that be. So we're actually established identity. So here's an example of using the fact that certain trig functions are even and odd. Because sine is odd, what does this mean? If we have sine squared of negative theta, we can rewrite this how? Yeah, because sine is odd, this is actually the same as. So here, let's actually do it. So yeah, that's. Go ahead. Mm. Basically, all the trig functions are odd except cosine and its reciprocal. Those two are even. Cosine is even and secant is even. Does that make sense? That's the simplest way to remember that, in my opinion, that I've come across. So I usually don't get into the Christmas spirit because I don't really like the capitalistic feel of it all. But I got to the point in my life I was like, you know what? If people can get along and like just let stuff go, it's like it's not even that serious. Like if we could just like be happy. Now, a lot of times I kind of imagine like, well, what if we were in that spirit 24/7? What would happen? Would it get old? Would we not appreciate it? But where I am right now is like I don't care anymore. I just want people to kind of stop fighting about stuff that we fight about and stuff that bends us out of shape. Okay, so now let's see if we can get this going. So let's start with a copy of the original. So, and let's get some paper. Let's do some graph paper. Okay, so we have sine squared of negative theta plus cosine squared of negative theta. We want to show that it equals 1. So we're going to say that this equals. So I want to say the following is just by definition. This is really just sine of negative theta quantity squared. Is that okay? That's what we mean by sine squared of negative theta. I'm just applying the definition of the exponent. Wait. I mean, is that okay? What I have written?
So that really all translates to negative sine.
Wait. Is this okay? What I've written? Okay, and I'm gonna do the same thing for this one. This should be the same as cosine of negative theta quantity squared. I think this is okay. So now, if this is okay, now earlier we said because sine is odd, sine of negative theta becomes what? Okay, so the first one becomes negative sine of theta, like this, and we're still going to say quantity squared. The second one becomes what? Yeah, so the negative essentially goes away. Because cosine is even, it becomes just cosine of theta quantity squared. Is that okay? So then what is it? What is negative sine of theta in this fashion squared? What is negative sine theta squared? What does this mean? What does that mean? So what does squared mean?
Squared means a number times or whatever times.
Yeah, so something times itself, right? So this means negative sine theta times negative sine theta. Okay? And then the last one becomes just cosine squared theta, right? So double negative becomes positive. So then this is sine squared theta plus cosine squared theta. And what does that equal?
That will go 1.
1, right? Remember right there in the green? We said sine squared plus cosine squared equals 1. Okay, so if we go back right here, again, this should equal 1, which is the identity that we wanted to establish. Okay, I think that's how that one goes. Let's go paper. Let's get rid of those lines. Okay, let's go back and see how do we do. So the first thing that I thought was a little bit of a stretch, but we did it proper. So we applied the definition of exponents, right? Or what we mean by sine squared of negative theta. It just means take sine of negative theta times itself, right? So then we applied the property of sine being odd. So sine of a negative is negative times the sine. Because cosine is even, cosine of a negative became just cosine of the positive. Then a negative squared became positive. Then earlier we said that sine squared plus cosine squared is 1. Any questions here?
So, for example, let's say you said sine over 1 equals 10. That would be, and sine over cosine, that would be sine over sine.
Let's find an example. Because I don't know that it always works out like that. Let's just find it. If we could find an example, we can walk through it. Let me. Of which one? These are trig identities, so these are simplifying trig expressions, right? Yeah. Let's just find some more examples. All right. Let's just kind of keep going there. That's about the best I can think to say there. So we want to show that the left becomes the right. So we can still. You feel like you guys can do this one? You want to give it a go? It's too bad we don't have a. I mean, you can work there. So let's take a few minutes and give this one a go, and then see can you get the left using the fact that we just kind of talked about the top, using the fact that sine is odd and cosine is even. Can we transform the left part into the right part? This is kind of a tangent. I just got finished watching South Park. I thought their latest episode was really funny. They, with all the like transgender discussion, they had one of their characters is called Strong Woman, and like she's kind of dating. It's so funny because she's dating her principal. The principal's name is PC Principal, so he's the principal of the school, but he has this huge thing about being politically correct. So like being sensitive to like everybody, but he's being insensitive because he's dating his subordinate. She's supposed to be a strong woman. It's like their jokes are like so interwoven and weaving and have so many different levels. It's not even funny. But this latest episode, so Strong Woman was entering like a Strong Woman contest, and she's like the reigning champion. So her name is Strong Woman, and she's like the Strong Woman champion. So that's like, that's like a enigma wrapped in a blanket kind of thing. It's kind of funny. But then the new challenger is a person that just recently started identifying as woman. And so you know who her challenger was? Macho Man Randy Savage. He was he in the show he recently identified as a woman, and so he entered this competition. He's like, I am going to beat the competition. You got the most macho manly person identifying as a woman entering a strong woman competition. I just thought that was hilarious. And then so because they're so politically correct, they can't just like flat out say, hey, you're cheating, because then it's being insensitive. I was like, that's hilarious in my opinion. I just thought it was really funny. It's really silly. Yeah, it's really funny. Like they just sit around all day and figure out, okay, how can we poke fun at, what's going on in society right now? Okay, so now hopefully you've had a few minutes to kind of look at this. Let's start by getting a copy of the original. Let's go to paper. Let's get some graph paper going. Okay, so here's a copy of the original. Sine squared of negative theta minus cosine squared of negative theta divided by, we got sine of negative theta minus cosine of negative theta. Okay. All right. Okay. Okay, so you mean like this, like negative sine theta quantity squared like this? Okay, that's fine. So the second one you're saying is cosine. If we apply the same concept, cosine theta quantity squared like that. Is that okay? Okay, divided by. Stop. You're like an hour late, my friend. 9:50. We got out. What time we get out? 10:50. Yeah, that's totally like an hour late. So glad I wasn't dependent on that. Okay. So you said the next one was negative sine theta. Okay, what's next? Minus. Cosine theta again, because cosine is even. So when we take cosine of a negative, it just essentially becomes positive. Okay, these should be equal. So then tell me about the top. Let's keep going. If we keep going, what happens next?
I'll tell you what I would have done. I would have, the division thing.
That's okay. I noticed that with me, like, I used to stutter when I was younger. That's because I was nervous. Now, if I do find myself stuttering, it's because I'm trying to rush. So, like, if I just like pause for a moment and like take a breath and slow it down and just not try to get everything out. Well, usually when I slow down, then it's like the stuttering stops. But when I was younger, it's because I was afraid, and then now it's just because I'm trying to rush. Probably still out of some kind of fear of being misunderstood, but that's a whole nother level. That's a whole nother thing. Uncertain, and that's okay. I mean, like that's what this whole experience is about. It's about being uncertain and like learning how to navigate the uncertainty. If we knew everything, we wouldn't be in school. The school is for learning how to navigate the uncertainty, and like on all that kind of stuff.
So I would have divided design with negative sine squared plus negative sine.
Oh, we're back to the same thing. These are terms, so we can't cancel these. Yeah, because so terms are things that we add and subtract. So we have two terms on top and two terms on bottom. So we can't cancel terms. We can't cancel terms. We can only cancel factors. Factors are things that we multiply and divide. So we're not at the stage where we can cancel just yet. But we can kind of keep going though. So we got that negative sine theta squared. So then a negative squared becomes double negative is positive, right? So let's account for that. So the top becomes, we have sine, it's going to become sine squared theta minus cosine squared theta divided by, basically negative sine theta minus cosine theta. Okay. So what else can we do to kind of keep going? We got something squared minus something squared. Did we experience that earlier today? Do you know what that factors into? Something squared. So we have difference of squares, right? That was a special factoring technique. Close. So if we have a squared minus b squared, what does this factor into? So this factors into.
I'm trying to say, like, I know the concept. Would it be
So let's back up.
A times.
We did it earlier. Hang on, let's back up. Right, not that one. Where is it? Let's go paper. Let's get rid of these lines for a moment. Okay. So right, let's highlight. Okay, so if we look at that purple, we got something squared minus something squared. So there again, we did a squared minus b squared. What did that become?
That'll be A plus B.
Keep going. A plus b times.
A minus B.
Yeah. So a squared minus b squared factors into a minus b times a plus b. That's difference of squares. That's a special factoring technique from like before calculus algebra. Okay, so now if that's difference of squares, if we go back here, what can you tell me about the top? So what should the top factor into?
That should be sine minus cosine.
Okay, sine of theta minus cosine of theta.
Sine of theta plus cosine.
Sine of theta plus cosine theta. Okay. Okay, so that's a different something squared minus something squared. So the bottom, how can we get the bottom to look like something that's on top? We have a negative sign minus cosine.
Multiply that second binomial.
Mm-hmm.
Negative 1.
Okay, so he noticed that there, it's just like if we can do something with a negative 1. Instead of multiply by negative 1, I'm going to factor out a negative 1 from the bottom, right? So if we factor out a negative 1, we're going to get negative times, it's going to become sine theta plus cosine theta, all right? Now, what do you notice happens? Now we can cancel. Notice it's all multiplication and division. Do you see the multiplication and division? So now we can cancel. So now this factor cancels this factor. If we distribute the negative into the top, because if we dividing by a negative is the same as multiplying by a negative. So if we distribute the negative here and here, what result do we get? That sounds good, right? I'm just going to change the order, but write exactly what you said. Let's go do that. Cosine theta minus sine of theta, and that's what we wanted. So also, all this stuff that you see me writing, I'm going to load a copy of it and make it available to you in our shared box folder before I walk out of the room. So all I have to do is load it to the box folder, and then you'll get a PDF copy of this document, right? So you'll get a copy of all this stuff that you see me writing. Okay, any questions here? Okay. All right, let me see, how much more? So let's go back here.
So next problem is the same concept. That was a little bit more
Okay. Okay, so we did that one. You want to give it a go? Okay. We don't have any much board space though. That's the only thing. Because that's not a touch screen, so you'd have to use this. So as long as you don't mind working here. So if you're not at the board, it's definitely a good idea to try this. Give it a try on your own. Hit some markers here. Okay. So the original is here. You can watch, see it there. Mm-hmm. 1 plus cosecant. Mm-hmm. So for the audience that's passive, what do you think might be the first move if we want to transform the left into the right? What do you think might be the first move? So earlier, one of the things that we said was we can write everything in terms of you can. It's a couple of different routes we can take, right? What does your first mind say to do as far as how to transform the left into the right?
Simplify and cosine.
Okay, so write it in terms of what sine and cosine, right?
Oh, okay, yeah, that makes sense.
Okay. So if you do that, cosecant is what? 1 over.
Cosine sine.
Okay, 1 over sine. So now, and there needs to be a theta there. So when we have a fraction within a fraction, that's called a complex fraction. To simplify a complex fraction, we want to multiply the top and the bottom by the LCD of all the fractions. All right. So we only have that one fraction. So what's the LCD there? Sine. So let's start by let's from that point let's multiply the top and the bottom by sine and see if that helps us. And if that doesn't work, I got something else that we can do. Let me think about this for a second. Hang on. So we get that plus 1, that. Okay, go ahead and see what happens. Let's keep going.
Theta squared or squared?
Sine squared theta. Okay. Now bottom, what happens?
That'll be sine over sine,
Mm-hmm.
which is 1.
Yep. Does that look familiar where you have the sine plus 1? Did you see that somewhere earlier?
Yeah.
Where do you see that? Yeah, you see it right here, right? 1 plus sine. So can we get that 1 plus sine to come back on the top?
You can. Think about it.
You can undo what you did. Like you don't have to keep pressing forward. So like on the top, you see how we distributed the sign? So if you factor out the sign, now you should be able to get something to cancel.
Right here. So sine squared plus cosine squared.
Mm-hmm. So let's factor out the sign. So basically undo the top. Put the top back to where it was.
So get it back to right here.
Mm-hmm. So just on our next line, you hit equals or drop down the line.
Like that. So sine theta plus 1.
Okay, so times sine of theta.
Sine theta plus 1
So
sine
the
theta?
numerator, you're putting it back to the previous. You're just rewriting the previous. 1 plus sine times sine. Because you distribute it, I'm just saying don't distribute. Does that make sense?
Let me go over here. So basically we're back here. But we're keeping this.
Mm-hmm. And you're still keeping that other sine of theta. So how you got the times sine of theta?
Oh, so this.
And
You need
and you need parentheses over here on the left. On the top. Yes, and yeah. Okay. So now we got 1 plus sine of theta divided by 1 plus sine of theta. What happens with those?
You know, just all turn to 1.
They cancel, they become 1, right? So then we're left with what result?
1 times sine theta over 1, which is just sine theta.
Yeah, it's just sine, right? Okay, so I think you got it. Do you mind walking us through what you did and why you do that? I'm going to write it down.
Okay, so we have 1 plus sine theta over 1 plus cosecant theta. So we want to write everything in terms of sine and cosine. What that means is if it's not sine and cosine, just simplify it because they all can be simplified. The cosecant, we know that's the reciprocal of sine, so we just say 1 over sine theta. And we had a fraction within the fraction. You see below the division bar or the fraction bar, we have 1 over sine theta. So the LCD, the least common denominator, that they all had in common was sine. So we just multiplied by sine. We got sine theta plus sine squared theta over sine theta plus 1. We can just turn the sine squared into 1 because it like not cancels out, but it just equals 1.
These are yeah.
And we got sine
squared these two?
to 1. Basically from here to here.
Oh, we factored out the sign.
We factor out that sign. So we just have 1 plus sine theta over sine theta plus 1 times sine theta over 1. This right here, it just reduces down to 1. Because basically sine over sine or 1 over 1. And we got 1 times sine theta over 1, which is just sine theta. And that's our answer up there. So we're supposed to do.
Okay, let me just get a copy of that. So you said, first you wrote cosecant in terms of sine and cosine. So you said that was 1 plus 1 over sine theta? Is that right?
Yeah.
This stayed the same.
Then I multiply it by sine theta.
Oh, the top and the bottom by sine and theta?
Yeah, because
so we multiply by 1 in the form of sine theta over sine theta. So on the bottom we're going to distribute. On the top I think we just left it. So the top just stayed as this, sine theta, 1 plus sine theta. But the bottom became
sine theta plus 1. Oh, okay, now I see how we factor.
And then that canceled, and we finished with our desired result. Yeah. Okay.
See, it's easier. I think when it comes to math, I'm really visual.
Yeah.
Because if you tell me it,
yes. Yes.
Show me it.
Yeah, like, well, math, that's my experience too. It's like watching it is one level, but you don't really get it. You don't really get it until you do it. Like, whoever does the most talking, whoever does it gets it, but if you don't do it, you don't get it. And it's like it's really that thing where everybody has to do it themselves, and if we don't do it, we're not going to see it. But that's just the nature of mathematics. It's not anything. It's just the nature of mathematics. Like it's a very active experience. And trying to encourage people to get active is like pulling teeth sometimes. Anyway, that's just me being negative. Okay.
When it comes to pre-cal, I feel like I really
go ahead and give this one a go. I think because this is essentially the same thing. See if you can get it to work.
No, I can't cross out. Can't. Just adding.
What time is it?
I guess I just looked at
Right. Okay. So here's another one. So what does your first mind say to do?
First mindset was to not write the 2 cosecant, just so
Okay. Yeah, just focus on the left, right? So that's fine. So if we focus on the left, we have this. Okay, this. Okay. So now if we're here, what would you do next? What does your first mind say to do?
Get a common denominator.
What is the common denominator?
Sine. We can do sine because well.
So the common denominator needs to be a multiple of all the denominators.
So then it will be 1 plus cosine times sine.
Yeah. All right. So for LCD, in this case, our LCD is 1 plus cosine times sine. We want to transform both denominators to look like that.
Oh, so then you do the first one, the sine theta over 1 plus cosine. You just multiply that by sine theta.
Okay. I think it sounds all right. Okay. So if we want both denominators to be like in the orange, the first one we're missing the sign, so we're going to multiply the top and the bottom by sine of theta. Okay. In the second one, okay, top and bottom by 1 plus cosine theta. Okay. Again, I definitely encourage you to go with your first mind, because I don't want you to build a habit of second guessing yourself, because eventually we'll start second guessing ourselves out of the correct answer. So we always practice going with the first mind. So then the first one, so on top, I'm going to leave the top becomes, we get sine squared theta. If we FOIL the second one, 1 plus 2 cosine theta plus cosine squared theta. And then both denominators are both sine theta 1 plus cosine theta. Is this okay?
So that's like the numerator, that's the final answer. Come on.
Yeah, we just put those two together, right? Because we said sine times sine was sine squared. And then if we FOIL out that second part, we should get what you see. So then, if we do that, what do you see that we could possibly do next?
All right, so we go to sine squared plus 1.
So what do you all see? What could we do next? What are some things that we talked about earlier? Does anything jump out at you that we talked about today? Anything jump out? What are some of the things that we talked about today? If we just ignore this.
We talked about, there's the sine squared theta plus cosine squared theta.
Okay, we see the sine squared plus cosine squared. What did we say earlier? So we have this, right? Sine squared, and we got this cosine squared. And actually, we got a sine squared plus a cosine squared. What did we say earlier about that? Sine squared plus cosine squared, right? Right. See that in green, the same thing? Is that okay? So sine squared plus cosine squared is 1, so those two together become 1. Did I share the story about the Zen master that went to the baseball game?
No.
There's a story of a Zen master that went to a baseball game, and the hot dog guy came around. He was like, hot dogs for sale. And he was like, hot dogs. And you know the Zen master ordered? He said, I'll have one with everything. So anyway, okay. Never mind. So it's a really bad joke. Okay, so sine squared plus cosine squared is 1, right? And so we went on to combine those. Let's bring down everything else. So this comes down, that comes down. Everything else just comes down. I'm just getting a copying of everything that's left. Okay. Ow. Okay, what do we notice now?
We can combine like terms at 1 plus 1.
Okay, I heard combine like terms. So if we combine like terms, we get this. Okay, do you notice anything at this point?
I think we could, something about the twos.
What about the twos? I heard something about the twos.
What was that I don't think we can necessarily do anything with that constant two, the normal two, but we could do something with that cosine too.
Okay, what are you thinking?
We can divide, well, should we divide that two by something? Because that, the cosine on the bottom, that's like a term.
Ladies, do you all see anything? Can we get the top to look like something on bottom so that we can get a cancellation going?
We can factor out the 2 cosine.
Okay,
So
I heard.
It'll be 2
Okay.
cosine.
Okay, I heard factor out the 2. If we,
2 parentheses 1 plus cosine.
1 plus cosine. Okay. Oh. 1 plus cosine. Okay. So if we do that, it gives us this. What do we notice? So now, is it visible? So this cancels this. What do we want? Where do we want to finish? 2 cosecant. So we should be home free. So at this point we have 2 over sine of theta, and this is equal to. Remember, see where we want it on the right hand side.
What about we have 2 twos. We have 2 plus 2 cosine. When you got the equal, it's just 1, 2. So what happened to that other 2?
Okay, what color are you feeling?
Blue.
Give me a random object.
Chair. You want a different one?
I was just thinking about what I wanted to draw. So I'm gonna do something kind of like this. The chair has like a leg.
But you know what I'm talking about though, right?
Just a moment. I'm still just kind of playing around. And then what I wanted to do was something like this. And some thicker lines, and I wanted to. That's fine. And then let's go like this. Okay. Okay. So now your concern is here. You can't really see that. Style. Okay.
My concern is about this 2 right here.
All right. Okay.
I know about this 2. We got.
So look. How can we take this and transform it back to this? What does this mean right here?
That means 2 times 1.
So how would we, if we were to work backwards, what is that technique called? Distribute, right? If we distribute the 2, are they equal?
Okay, yeah. Oh, okay.
Right?
Oh, it's all. Okay.
Okay. So if we distribute that 2, that'll be in there. Okay. So then now, if we look at the original, where did we want to finish? Is this 2 cosecant theta? What is cosecant? Sine. Is this 2 cosecant theta? Yeah, right? Because 1 over sine is cosecant, so the 2 just comes down, and the 1 over sine becomes cosecant theta. This is what we wanted. Okay. So style, let's go like this. Okay, I think that's what we wanted. Let's go like this to paper. Yeah, we gotta keep practicing through the exams, not to the exam. Like, just keep going through it, and it'll lock it in. Again, we don't want to work something until we get it right. We want to have worked it so many times that it's impossible for us to get it wrong. Okay, so I think they essentially did what we did. Let me think about it real quick. Yeah. So yeah, they did the same thing we did. Let me see how many. Let's see, is there one more after this? There is another one. How much time do we have? Like 30 minutes? Okay. Let's do one more, because I want to get some practice. I want you to get a chance to get started on your homework. And so, like, you can work on your homework for the last little bit of class, and you can ask questions while we're together. So you can, if you want to work on this, you can. I actually kind of want to stop here. Let's go ahead and just, for the last 30 minutes, let's kind of, we can either, like, you can do homework. So you can either do the homework for this section. It's only 2 more examples here. I'm going to leave those as exercises. But you can either work on the homework for this section, you can work in the book, or you can work on Pearson. Pearson is not required. It's just available for you. So if you want to work solely in the book, that's perfectly fine. So let me see. So I want to do at least one more section. There was something else that I wanted to mention. But yeah, okay. So yeah, we'll just use the rest of the class time, this final 30 minutes, to just get some practice. Okay, so we're here to kind of work together. I'm here to answer questions. If you're having trouble registering for Pearson and you would like to register for Pearson, just let me know, and I can make sure to get you in there right now. And yeah, the main thing is just to be practicing. If you want to work in the book, that's fine too. It's all the same information, just different presentation styles. Is there a question? You have a question? Go ahead. Okay. Okay, so on that note, we're going to end this session here. Okay, and so from one beautiful mind to another, enjoy the rest of your day. Go back here.